So the next thing to speak about is macrophage lymphocyte interaction. So we have the T helper 1 cells, these guys. This page is basically like the page in kidney, if you remember. There was that page in which was really difficult, but we kept going back to it. The same thing is here. So the T helper 1 cells secrete interferon gamma, which enhances the ability of monocyte and macrophages to kill microbes they ingest. Let's start speaking. What is the difference between monocyte and a macrophage? What do you know about the difference between monocyte and a macrophage? Which one is located where? Yep, that's all correct answer. So the monocyte is normally located inside of the blood, but when it moves inside of the interstitium, we call it a macrophage. Yes. Okay, good. Let's keep going. So they write for us the following. The interferon gamma makes the macrophage and the monocyte much more stronger. So when you ingest something inside of the macrophage, you have lysosome and you have a phagosome. And when you bind them together, you have something called the phagolysosome. You have a vein, you have binable. You have a lysosome and you have a phagosome. So you will have a phagolysosome, okay? So, and after the creation of the phagolysosome, you want to activate the macrophage to make him much more potent. And for that to happen, you have to have an interferon gamma, which comes from the T helper 1 cells, which is activated from whom? From this guy, the T helper 4. Okay? So, let's keep going. So this function is also enhanced by interaction of the T cell CD40 ligand with the CD40 on the macrophage, which is in this picture. Where it is? Yep, it's here. Speak about it in a momento. So, macrophage are also activated by lymphocyte via antigen presentation. So, macrophage can be enhanced by multiple ways, either by antigen presenting cells enhancing it, like this. See, the MHC class 2 in the antigen presenting cells, which is the B cell, is binding to the T cell receptor. Also, it can bind to whom? The macrophage. And that can lead to activation of it. Also, we had another mechanism which was due to the secretion of interferon gamma, which was secreted by the T helper 1 cells, which used to do the cellular stuff, yeah? So the next thing is cytotoxic T cells. It kills virally infected cells, neoplasm, and donor graft cells by inducing apoptosis. Okay. How do we induce apoptosis? Remember, guys, it was the extrinsic pathway. So it was either with the Fas ligand or the perforin's gran enzyme. Yes? So it released cytokines granules containing preformed proteins, which are the perforins and the gran enzyme. Perforin perforate, it destroys the wall, and the gran enzymes goes in and activate something called caspases. These caspases lead to degradation of inner product of the cell, leading to its destruction, which is basically apoptosis. Okay, cytotoxic T cells have CD4, okay, which bind to the MHC class 1 on virally infected cells. Which has other cell we spoke about today, but it was, of course, guys, one momento. This cytotoxic T cells, it's a lymphocyte, and it's a part of the acquired immune system. Which other cell did exactly the same function, but it was a part from the innate immune system? Which cell is a part of the innate immune system? It's also a lymphocyte, and it did the exact same function as a cytotoxic T cell, but it's not a cytotoxic T cell. It's the natural killer cell. Exactly, it's a natural killer cell. Okay, good. The next thing is something called the Treg, regulatory T cells. They help maintain specific immune tolerance by suppressing the CD4 and the CD8. T cell effector function. So these regulators, remember the friend zone guy, he's just dealing with the trash. He has to suppress other guys like the CD4 and CD8 and tell them don't fall into that trap. So it basically decreases their function. Why it's important? Because if this guy is dysfunctional, a problem will happen. So let's see what happens. So it's identified by the expression of the CD3, 4, CD25, and most important thing here is the FOXP3. FOXP3. Activated regulatory T cells, which is Tregs, produce anti-inflammatory cytokines, which are basically the interleukin 10 and the TGF-beta. Let's imagine someone has Ibex syndrome. What is this Ibex syndrome? Remember what I told you the most important thing they express was the FOXP3. So if you do not have a FOXP3, this guy, you are going to have dysfunctional regulatory T cells, which can lead basically to autoimmunity because these guys used to destroy the cells that were autoimmune. So it's characterized by enteropathy, which is like an intestinal problem, endocrinopathy, which is like multiple endocrinological autoimmune disease, nail dystrophy, and dermatitis. But this is also all bullshit. What they give you, and you must recognize, is the FOXP3 and the male child with diabetes. That's what they give you, okay? So yeah, they do have a rash and all of that, but the main thing is the FOXP3 and diabetes in a male infant, okay? Good. Let's take a look at how the T and the B cells get activated. And then I believe we'll explain a couple of words here. We will not explain the exact graph, but we'll speak about a couple of words here and call it off. But for now, let me see. So yeah, I think we will finish this and go to biochem to finish this page. That will be good. We will be done with like 5 pages today. Okay, so here we have the following. T and B cells activation, antigen presenting cells. B cell, what are the antigen presenting cells? Here we go. B cells, dendritic cells, Langerhans cells, and macrophages. Guys, what are Langerhans cells? Does anybody know what is Langerhans cells? Langerhans cells. It's not Langerhans cells, it's Langerhans cells. It's a macrophage of which organ? It's the macrophage of the skin, guys. It's the macrophage of the skin. Macrophage of the skin, we call it Langerhans cells, okay? Macrophage of the liver, we call it Kupffer cells. Macrophage of the lung, we call it dust cell. So each organ, its macrophage is named differently. But if it is in the skin, we call it Langerhans cells, okay? So let me send that. Okay. Good. So we have the antigen presenting cells. 2 signals are required for T cells activation, B cell activation, and class switching. So we'll speak about the process of class switching in a moment. This is high yield. T cells activation. Dendritic cells, which are specialized antigen presenting cells, ingest and process an antigen. After processing this antigen in the periphery, they migrate and they drain into the lymph node. So now they are in the lymph node. T cell activation with signal 1 occurs. How? Exogenous antigen is presented on the MHC class 2. Why MHC class 2? Because they are antigen presenting cells. And they are recognized by the T cell receptor. So they write MHC class 2 on it, you will have antigen presentation. and it will be recognized by the T cell receptor on the T helper CD4 cell. Endogenous or cross-presented antigen is presented on the MHC class 1 to the T cell CD8 cells. Why this is important? Because if you present it to the CD8 cells, it will be killed. But notice here the difference between these two. The first one is CD4, and the CD4 was for exogenous antigen. Yes, it is exogenous antigen. While when we spoke about endogenous antigen, it was the CD8. Yes? So, exogenous antigen. Are they speaking about bacteria or viruses, guys? Exogenous. Exogenous antigen is bacteria. Yeah. Bacteria. What about endo? Viruses from the inside. Yeah. So proliferation and survival is signal 2. So notice the first signal was here. It was a connection between the MHC and the T cell receptor. That was the first signal. The second signal is this one. It's a proliferation and survival signal. It's a co-stimulation co-stimulatory signals via the interaction of the B7, which is located on the antigen presenting cells like dendritic cells, and the CD28, which is located on the naive T cells. Okay, so these two interact with each other. When they do interact with each other, they will be what will happen to you? Your naive T cells will be no more naive. She will become a mature T cells, okay? And it will start producing cytokines. So notice you needed two signals. Signal number one, MHC with T cell receptor signal. The MHC class 1 or 2, depending on if it was exo or endogenous, basically led to the cross-linking with the T cell receptor, which led to basically activation of the naive T cells to become an activated T cells. While the co-stimulatory signals, after the first signal happened, they make sure that this process will keep going, okay? So activated T helper cells produces cytokines. So T cells able to recognize and kill virally infected cells, which is this guy. Now he can play an actual function in life. So this is the process of the T cell activation. Well, if you get T cell activation, B cell activation is super easy. Remember, T cell activation was mostly like a creating of an active CD4 and CD8. Well, and you remember that CD4 can activate even B cells. So basically T cells can activate B cells. That's what I'm trying to say. So now we have something called the class switching, the B cell activation and the class switching. So T cells activation happens as above. Now you have an active T cell. So what's next? B cell receptor mediated endocytosis. Here is the B cell. You have endocytosis inside of it. And now you have exogenous antigen from the outside is presented to whom? MHC class 2. Guys, MHC class 2 is present only on the antigen presenting cells, like B cell, for example. And it will be presented to the T cell receptor on the T cell, obviously. So then you will have, again, co-stimulatory signals. In case of the T cell, it was the B7 and the CD28. Now it's the CD40 and the CD40 ligand, okay? So it's the CD40 receptor on B cell ligand. And yeah, this is bad actually, but you must know that the ligand is located at the CD4. Remember, guys, when I told you that the CD4 is basically the godfather? So the godfather, I just like to imagine that the godfather has a cane, you know? So he has a cane. And that helped me to just like imagine that it has the ligand, because a letter L look like a ligand, yeah? So CD40 receptors on the B cells bind to the CD40 ligand, which is located on the T helper cells, okay? And that will lead to activation and secretion of cytokines from the T helper cells, okay? Which then they determine the IgE class switching of the B cells. So what is class switching? Well, normally all of your cells make the exact same antibody, okay? So this antibody, all B cells make IgM, okay? All of them. Then they undergo the process of a class switching, in which that IgM can now become IgG, IgA, or whatever Ig it wants, okay? That's class switching. So T helper cells secrete cytokines that determine the Ig class switching from the B cells. For example, if it was an eosinophils, you want to make an IgE. If it was, let's say, a bacteria, you want to make an IgG, okay? And then we have B cells are activated and they produce IgM. They undergo the process of class switching to determine which immunoglobulin we want to secrete and affinity maturation. And that's it for these 4 pages. Now I'm going to go really quick over that last page of biochem. We just have 3 more concepts to explain. Super easy peasy. We'll finish them up, ask you one question, and then call it off for the day. So histone methylation, it has methyl in the name, so you start thinking about muting. Yes, so usually causes reversible transcriptional suppression. It stops the transcription, but also can lead to activation depending on the location of the methyl group. This is basically telling you that some places, if this process of histone methylation will occur, it will reversibly activate. But in your exam, you must keep in mind that mostly methylation equal to muting. That's it. Do not get confused with this portion. If they do not tell you that methylation is leading to activation, don't think about it, okay? So histone methylation mostly makes DNA mute. So histone acetylation, so it's activation. Removal of the histone positive charge. So remember, the histones used to keep everything stable. Let me ask you this. What gave histones their positive charge? I told you DNA had negative charge because of the phosphorus. What about histone? Excellent. I did not expect someone to know that. Okay, lysine and arginine. Excellent job. So, yes, it's lysine and arginine. It's mentioned here. Yeah, lysine and arginine give the histone their positive charge. Okay, so they get removed by histone acetylation, which relaxes the DNA coiling and increase the transcription. Okay, less coiling. Why less coiling? Because you don't have histones. Yeah, that will lead basically functional histones, which lead to more transcription. So thyroid hormone receptor alter thyroid hormone synthesis by acetylation. Okay, dysregulated acetylation is implicated in Huntington disease. In case of Huntington disease, we are going to speak about it in neurology. In that disease, patients tend to have quite a few symptoms like dementia, they are really angry, they have family history of it, and the most prototypical thing to know that they have the chorea. Chorea is an improper movement of their limbs in which they start like just jerky movement all over the place. So histone acetylation make DNA active. So acetylation activation always. Methylation means muting. Guys, just think about it. Histone deacetylation. Will it lead to deactivation or activation? It's deacetylation. Will deacetylation lead to activation or deactivation? Yes, deactivation. Excellent. See, it just becomes a second nature of you. So they remove an acetyl group, which tightens the DNA coiling, which lead to reduction of the transcription. So you have less transcription, yes? Let me ask this. If you have less transcription, is this process more in the euchromatin or the heterochromatin? No. Look, less transcription is happening, which mean basically it's sleeping, no transcription. No transcription. Let me ask this then. Less transcription is occurring at the black area or at the white area? Which one is inactive? The black is inactive, which means basically decreased transcription is happening in it. Yes? So we can say that if they give you a question, they show you this and they give you arrows. They actually love to do this. 1 and 2. And they tell you which of the following has the process of deacetylation. So you need to think deacetylation, deactivation. Which one of these two is inactive? So which one it is? Two, which is the heterochromatin. Excellent. If they tell you which one of the following is undergoing massive demethylation? Demethylation. Which one of the following has reduction of the methylation? Less methylation, what does it mean? If you have less methylation, you have more activation or less activation? More activation. So more activation is occurring at 1. Excellent. Good. Yep. So that's how they give you the question. This is exactly like I saw the exact same question on my personal test. So please know this concept. So, okay. Yeah, and that's it for today. We did 5 pages in 2.5 hours. I can start to feel that we are picking up the speed, which is good. Hopefully we will not lead any prolongation if we keep going this way. For the previous couple of days, I was kind of scared that we will not cut it until my plan, but I can tell you today that I feel more comfortable. If we keep going with this pace, all will be fine. So I will meet you guys on Monday. Tomorrow is off. Have a happy weekend and see you later, everybody. Bye bye.